Okay, we're back with Simul8, and we're attempting to input the probability distributions. All right, data and rules, create distribution, probability profile. Okay, so let's see. 20. Let's call this arrival. Arrival 1. 20 for the point 2. 20. 30. 20. 5. 5. And the rest is 0. And let's put the labels. So this is 5 minutes, 10 minutes, 15 minutes, 20, 25, 30. And let's delete these. Right hand click, right mouse click, delete, 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 and delete. All right, this looks good. We have our probability distribution function here for the inter-arrival times. And let's save it. Okay. All right, let's create the service time. So let's call it service 01. And let's start with the labels. So it's also 5, 10, 15, 20, 25, 30. Okay. And let's delete these. Alright, and seems to be something a little wrong here, but let's see. Point 1, this should be 10. This is also 10. Oops. So you can drag this up to 10. And let's lock it. You can also do it this way. Alright, this should also be a 10. And let's lock it. Right click with the mouse. Lock. 20. Right click with the mouse and lock it. Another 20. 30. And this one should be 10, right? 5, 10, 15, 20, 25, 30, 20, 40, 60, 90. This one is giving me a little bit of a problem. Let me add one. Insert. So this one should be 30. All right, let's see. This one is 10. And let's lock it. This one is 30. And lock it. 20. Lock it. 20. And 10 and 10. So there seems to be something wrong with this new version of Simul8. But these numbers don't seem to add up to 100. Perhaps it's just a bug. They have some programming built there. But let's just leave it the way it is. This, though, should be 5 minutes. So 5, 10, 15, 20, 25, and 30. All right, so we have our distribution set up. Okay, so let's look at the one-man barbershop. I have a start point. We'll have a queue. We'll have an activity. And we'll have an end. Okay, now we just programmed in the interarrival time. So now we can choose it from here. So this is actually using the probability profile that we programmed in. It's not an exponential anymore. We can actually use a real probability distribution that comes from data, perhaps a histogram of real data. And for the server, let's choose the one we just programmed in, service 01. Okay, and we're all set. Let's go back home up here. Run it for 1 year. Run it fast. Not too good. It looks like our queue blew up. Average time spent in the system, 15,000 minutes. So clearly the system is not working. We need a lot more help. Alright, so let's see how many we need to get things under control. So let's right click, duplication wizard, So let's try 3 more copies of the server. All right, let's see if this is enough. Reset and run. It's going through the year. So far, it looks pretty good. There's a 0 wait time on average. Almost no wait time. So we don't need this much help. So let's delete some of them. So just hit the delete key. Let's try it with 3. Very, very low wait time. So maybe we just need 2. All right, this is more reasonable. So it looks like we have an average wait time of 1.79 minutes. All right, now suppose that after, let's delete these arrows here. Click on the arrow and you can delete them. Let's add something else to this queue. So suppose now, after going through this activity, a certain number of the outputs will go to a new queue and a certain number can exit. So let's say there's a production process and some of the outputs are defective. So the defective ones will go to a new queue, the new activity, and then they can leave the system. So let's route it out. Okay, so how is this going to work? Click on the activity, go to routing out. So where can you go from activity 1? You can go to the queue for activity 3, that's this one over here, or you can end right away. So suppose that 10% and 90%. So 90% are fine. The 10% have some manufacturing error. So 10% are going to go to this queue here, which will have to go to this here. And suppose this is an exponential with average, say, 10 minutes. Okay, and then they can leave the system. And for this activity, suppose the same thing. And let's route out here. Suppose for this activity, it's not as good, so 20% and 80%. So 20% are defective and have to go here to be reprocessed. All right, so let's run this slowly first to see what it looks like. Just run it slowly to see that it's routed properly. All right, let's pause it. Let's run it really fast. All right, so let's see what happened. So the average weight here was 0.78. All right. Average time in the system, 25 minutes. Average weight here, 1.79. So let's say we slow this down a bit. Suppose the average time is 40 minutes. Average time to fix a defective product that comes out of either of these activities, 40 minutes. So let's run it again and see how things changed. Well, average wait time is 28 minutes now. Average time in the system, 34 minutes. Let's slow this down even more. How about 100 minutes? All right, so we see we have a problem here. So there's a bottleneck in our queuing system. 5,000 minutes. All right, so let's try to duplicate this one. Let's make another 3 copies. And it looks like it routes it nicely. Yeah, it looks like it's routing it properly. All right, let's reset and run. No problems. So let's delete a few of these. Let's try deleting one. Oh, still doesn't seem to be any problems. All right, average time here, 5 minutes. So let's try deleting one more. And now things are starting to get a little worse, 41 minutes. All right, so notice that you could just keep on adding queuing systems. For example, if you deleted this, then you could simply add another queue. And another activity. And go on to the next phase in your system. And then we can end here. So this would be a bottleneck. Suppose we have a uniform distribution. So uniform Lower bound, let's say, is 2 minutes. Upper bound is 12 minutes. So as you can see, things are not very good, and it looks like we have to fix this system. And you could play around with adding more activities and figuring out faster ways to improve the various activities. All right, so this concludes this video. Notice just the most important thing here is this, that's new at least, is these distributions. And well, it looks like this one's okay. And the service time. So as you can see, it looks like it rounded these things. So perhaps we can fix it now. 10, 10, 20, 20, 30, and 10. All right, all fixed. Now everything, I guess everything always added to 100%, except we were looking at rounded data. All right, so you should practice everything we've learned here. Between these two videos, you should now be able to solve many of the exercises in the textbook in the chapter called Process Model.